Here we go, 7.7 again, but this time we're on day 3. Day 1, we learned how to find sides of a triangle. Day 2, find angles of a triangle. Day 3, solving right triangles. What does it mean to solve a right triangle? Well, every right triangle has 6 parts to it. I know you're thinking 3 sides to a triangle. 6 parts to a triangle. It has 1 right angle. Every single time it has 1 right angle, no matter what. And it also has 1 hypotenuse every single time, no matter what, because of that. But it also has 2 acute angles. And it has 2 legs or sides. So basically it has 3 angles and 3 sides. We'll always be given that it's a right angle. So we know that every single time. It's a matter of the other 5 parts. Can we find the other 2 acute angles, the hypotenuse, the legs, or the sides of the triangle? To solve a right triangle, they either have to tell you 2 side lengths every single time, or they have to give you at least 1 side length and 1 acute angle. So without 2 side lengths or a side length and 1 of the acute angles, we cannot solve a right triangle. And remember, we already know that it has a right angle in it also. So we'll have 2 side lengths and a right angle, 1 side length, 1 acute angle, and a right angle. So we're going to have to find the other 3 parts of the triangle. And let me remind you, they can't tell us 2 side lengths. They can tell us 2 side lengths, but they can't tell us 2 angle lengths, because if I had 2 angles and their sizes, I'm going to clone this, those angles are the exact same size, but that's not the same size triangle. The angles are still the same. The angles are still the same. The angles are still the same. But you can't tell me that you can solve that triangle if they gave you 2 angles. You have no idea how big the triangle is if they only gave you 2 angles. So you always have to have at least 1 side length to put it in perspective. Okay, so taking a look at this, it looks like, go ahead and draw it, pause it if you need to. It looks like we need to know how big angle P is. We also need to know the length of side PQ, and we need to know the length of side QR. So we need 2 sides and an angle. We have an angle, we have a side, and of course we always have the right angle. How are we going to do this? We're going to combine the 2 days of information that we already know. Checking out this 37-degree angle, we definitely know that we have the hypotenuse. Let's find angle P. Since this is given and this is given, we can just use the triangle sum theorem. Find angle P nice and easy by saying 180 degrees minus 90 minus 37, or a nice little shortcut. The 2 acute angles are always going to add up to 90 degrees. So instead of taking 180, you can just take 90 minus 37, and you get 53 degrees. That's the easy one. Now let's find the sides. Where is PQ in relation to this 37 degrees? It's all the way over on the opposite side of the triangle. So if we're looking for PQ, we have the opposite side, we have the hypotenuse, O and H is SOHCAHTOA. We're going to do the sine of 37 degrees equals opposite. We don't know, but we know it's side PQ over hypotenuse, 22. Variables in the numerator, all we have to do is cross multiply. PQ is 22 times the sine of 37 degrees, which will be approximate, and we'll go to the nearest tenths. So if we take 22 times the sine of 37 degrees, we'll get 13.2. 13.2. Okay, let's find QR. How do we find QR? QR is the adjacent side, meaning we need the cosine of 37 degrees equals QR over 22. Again, we know we're looking for the variable QR. It's in the numerator. We can just cross multiply this up to the front. So QR is 22 times the cosine of 37 degrees, which is approximately 17.6. Double check, both sides should be smaller than the hypotenuse, which they are. Notice we didn't have to use inverse sine or inverse cosine this time, because when trying to find this angle, we already knew by the triangle sum theorem how to find that angle. So we only needed to use sine and cosine. But I bet on this one we will have to go ahead and pause this, draw it if you have to. Take a look at the three parts we know. We know the right angle Q. We know side QP. We know side QR. We do not know side RP. And notice I didn't put the bar over it because we're looking for the measure. We also don't know the measure of angle R. We don't know the measure of angle P. We've got to find them both. So let's find the third side. How do we find the third side if we don't have an angle measure yet? We can't use sine, cosine, and tangent of 90 degrees. So some of you are racking your brain like, I don't know if we can find the third side. Let's find an angle first. But that's not good, because what if we find the angle wrong? Or what if it's going to come out to a random or an irrational decimal, and we won't be able to use the exact angle? Go back to your roots. Find the third side of a right triangle. You probably forgot all about that. A squared plus B squared equals C squared. We're looking for RP. 11 squared plus 18 squared equals 445. The square root of 445 is 21.1. So we'll go 21.1 for our third side. Okay, now we can find angle R and angle P. We will not use this information because it wasn't given to us. We just did it to find the answer. We're going to use angle R, or we're going to use the given information to find angle R and angle P. So we're going to start with angle R, mark it. Where is the 11 compared to the angle R? It's all the way over here, it's opposite. Where is the 18 compared to angle R? It is adjacent. Opposite and adjacent. What uses opposite over adjacent? The cosine. No, it doesn't. Don't listen to me. What uses opposite over adjacent? Maybe I should spell out my SOHCAHTOA. Opposite and adjacent is tangent. But because you're looking for the angle measure, not the side, we're not using tangent. We're using inverse tangent. That helps you find the side. What's the inverse tangent of angle R? Opposite over adjacent. Go ahead and type in inverse tangent of 11 over 18. Reminder, we will call it the inverse tangent, not the tan negative 1. 31.4 degrees. Approximately, it's not exactly, 31.4 degrees. We need to find angle P. We're switching it. This is no longer our angle marking. Our angle is now down here, angle P, which means this isn't opposite anymore. This is opposite, and this is adjacent. So when looking for angle P, we're going to take the inverse tangent of 18 over 11. What is the inverse tangent of 18 over 11? You probably guessed this already. It's 58.6. How would you guess that it's 58.6 degrees? Because you maybe took 90 minus 31.4. If you add those up, they come out to 90.0. But I will warn you again, don't use found information to find new information. Number one, this was rounded. Maybe you rounded it wrong. Maybe you calculated it wrong. Maybe it's not exact. And number two, you don't want to make one mistake here and then automatically make a second mistake there. So do it right, do the work, and then check your answer. I would say go ahead and solve this one by yourself, but I already know what mistake you're going to make, or some of you, what mistake you're going to make. First, check and see what we're missing. We definitely don't have a TU, we don't have angle S, and we don't have angle U. What do we do when we have two sides and not the third side? We do it just like this problem, where we had our 18 and 11, and we used Pythagorean theorem. But, be careful. Careful when you use the Pythagorean theorem. We are looking for UT or TU. Make sure you use your Pythagorean theorem properly. 23 squared minus 7 squared. UT equals, UT squared. Don't take 23 squared minus 7 squared and call it 16 squared, please. That's against the rules. You'll go to mathematical jail if you do that. 23 squared minus 7 squared is 480. If you took 23 minus 7 squared, you would have gotten like 456. Not the same. 480, you square root that, UT equals, and we're going decimal. Isn't that nice compared to breaking it down? The square root of 480 is 21.9. We are not using that for further information. We're just using it to get the answer. Now we're going to find angle S, knowing that you have the adjacent side to angle S and you have the hypotenuse. To angle S, adjacent and hypotenuse is cosine. So we're going to do the inverse cosine of 7 over 23. Adjacent over hypotenuse, inverse cosine 7 over 23 is 72.3, approximately 72.3 degrees. How do I find U? U, I'm going to switch it to over here. Now that's no longer adjacent. It's now the opposite. Opposite over hypotenuse is the inverse sine of 7 over 23, which is 17.7 degrees. Double check and see if you got them right. They should add up to 90.0. Last one, find it on your own. Find X, find Y, find the measure of angle A. On your mark, get set, go. Okay, you should be back. Looking for X. Trying to find X. Did you use tangent, opposite over adjacent? Did you cross multiply? 33 times tangent of 24 is 14.7. Looking for Y. Did you use cosine? Because you needed the hypotenuse, but we're given adjacent. Cosine of 24 is adjacent over hypotenuse. Trade places with them, cross multiply and divide, which is the same as division here. 33 divided by the cosine of 24 degrees is 36.1. How do you find A? Corollary to the triangle sum theorem, you know that these two add up to 90. 90 minus 24 is 66. If you can do any of those, Pythagorean theorem, sine, cosine, and tangent, and some inverse sine, cosine, and tangents, you're good to go. Solving right triangles. Good luck.